Maths educational video. Order of integration. Let's do some revision. When it comes to double integral, besides rectangular domains, we've also learned type 1 domain, where x lies between two constants and y lies between two functions. The double integral to compute will be this iterated integral. We integrate f with respect to y and then with respect to x. If the domain is of type 2, in which y lies between two constants and x between two functions, then we'll compute this integral instead. First y with respect to x, and then with respect to y. It's possible for a domain to be of both type 1 and type 2, as illustrated here. So here's an example of a domain D, which can be viewed as both a type 1 region, where x lies between two constants and y between two functions, or, if you change your perspective, this can be a type 2 region. Here y lies between two numbers c and d, and x between two functions g and h. So when this happens, the double integral can be computed either by using this iterated integral corresponding to type 1 region, or the second one for the type 2 region. They have the same values. So the natural question to ask is, which one should we use? If the function f is something easy to integrate, for example, power functions like polynomials, then it really doesn't matter which one you use. But there are occasions when one is difficult or even impossible to do, while the other one is easy. So in that case, if given the one that is impossible or difficult to do, we will have to change the order of integration. And by that we mean we change from one type to another. So the objective of this video is to learn the techniques for doing that. So here's an example to illustrate the techniques of changing the order of integration. But first let's inspect the integral to find out why we have to change the order of integration. Actually, it's not difficult to tell. If we do this directly, we will have to first compute the inner integral as usual. But immediately you run into trouble because sine of x squared cannot be integrated. There's no way we can do this. So whenever this happens, you would have to try to change the order of integration. What it means is, instead of doing x, y, we change the order to yx. So you integrate the function with respect to y first. So that should be your inner integral, and then with respect to x. In order to change the order of integration, you will first have to find out the domain of integration. So that will be the first step. Once you are done with this, you will change the given integral to the other type. So for example, if the given integral is of type 2, which is what happens here for this particular example, you try to write it as a type 1 integral. The particular integral is of type 2 because in this integral, x lies between two functions of y, while y lies between two numbers. The one with numbers will always be the outer integral. And our job is to change it to type 1, where x lies between two numbers. What they are, we have to determine after step 1. And y will lie between two functions. So we do step 1, we sketch the domain of integration. And to do so, we make use of the integration limits. First, with respect to y will lie between 0 and the square root of pi. So the one in red. As for x, it will lie between y and square root of pi. So think of these two as functions of y. This is a constant function and this is the straight line, x equals to 1. Once we have the inequalities for both x and y, we will sketch the boundaries. And by this I mean, you will set the inequality sign to equality sign. For example, x more than or equals to y, we will draw x equals to y. As for the other inequality, you will sketch x equals square root of pi. You do the same for the other inequality. So in total, there are 4 graphs to draw. X equals to y, x equals to square root of pi, and also y equals to 0, and y equals square root of pi, as shown in the diagram. And once you're done, based on the inequalities, you can get the region of integration, which is the region D shown on this slide. So that's how we get the region of integration. And with this region at our disposal, we can now change the order of integration easily. As I mentioned before, the given integral is of type 2, where y lies between 2 numbers and x lies between 2 functions. And now we want to do it the other way around. We want x to be between 2 numbers and y between 2 functions. And that can be done easily by just inspecting this region. So as far as this triangle is concerned, x lies between 0 and root pi, while y lies between 0 and this line, which is y equals to x. And once you have these two inequalities, you can easily write it in the form we want. So here's a quick summary. The given integral is of type 2. The inner integral, which is in green, is impossible to compute. Now we change it to type 1. And the inner integral, which is the integration of sine x squared with respect to y, is very easy to integrate. I'll elaborate this later. So let's compute the type 1 integral. The reason why this is easy to do is obvious. When you're integrating with respect to y, sine x squared is a constant. So you can take it out of the integral sign. And you end up integrating 1 with respect to y. So this integral will become x after substituting the integration limits 0 to x. So you end up with the integral of x sine x squared. Recall what you learned in single variable calculus. This can be done by the method of substitution. And that's because x is related to x squared. In fact, the derivative of x squared is 2x. So when the integral has this format, we can do it by substitution. Don't forget to change the integration limits. So here's a reminder, because we are changing the variable from x squared to u, so the corresponding integration limits have to be changed as well. And we get the final answer of 1.